We are now at part C of question 8 of the January 2021 CSEC Mathematics past paper. It says Monty is cycling at 12 meters per second. After 4.5 seconds. Alright, so you have 12 meters per second here. After 4.5 seconds, right, which is this point here, he decelerates. You have the deceleration, and after a further 2.5 seconds he stops. So it's 4.5, 5.5, 6.5, then 7. Okay, good. The speed time graph is shown below. Calculate the deceleration. Alright. Now, I copied the question and put it here already. We're going to calculate the deceleration. Of course, deceleration is the change in speed divided by time. Alright? If you study physics, you would have also seen where the final velocity is initial velocity v equal u plus acceleration by time. So when you transpose for acceleration, which is deceleration is the same as negative acceleration, what you would get for that formula is v minus u over t, change in velocity divided by time. Alright? So the change in velocity here would be 12 minus 0 over the time it takes, which is 2.5 seconds. It's 2.5. In that case, what you have is going to be 12 divided by 2.5 equals 4.8. So it's 4.8 meters per second So it's meters per second squared for the constant deceleration. This acceleration here, if you put acceleration, you'd have to put a negative in front, but since they ask you for deceleration, you say d is 4.8 meters per second squared. Alright? So the deceleration is 4.8 meters per second squared. But it is a negative acceleration. Alright, so in that case it slows down right to stopping. Now, here it asks you for Monty's average speed over the 7 seconds. What's the average? The average speed over the 7 seconds. So the total, the average speed. Well, here you have speed and then a deceleration. Now the average speed will be the total distance covered divided by time. So that's one way to think of it. Now, the speed, SA for average speed I put there, is the distance divided by time. How would I calculate the distance? Distance is equal to speed times time, right? Speed times time would be the area under this graph. Right? Speed is the height, time is the width. So height times width would be speed times time. How do I calculate that now? Let us see something here. This area here, let me redraw it. This area, alright, the area here would be half base times height. Half of the 2.5 times 12, which is what? Let's reach for our calculator again. our calculator. Let's try that again. Calculator. Alright, let's use this calculator. Half times the base 2.5 times the height of 12 equals 15. There are 15 meters. You would have covered 15 meters here. This area here would be 12 by 4.5, which is what? 12 fours 48 plus 12 by 0.5 is 6. So 48 plus 6 would be 54 meters. Alright? So 54 meters plus 15 meters. So total area, which will be the distance. Right? The total will be 54 plus 15. What's that? 5 and 4, 9. 5 and 1, 6. 69 meters. That's the area under the graph representing the distance. 69 meters. So distance is 69 meters. Time is 7 seconds. So let me put AVG for average. The average speed would be the distance 69 divided by 7. What is 69 divided by 7? Let's do that. 69 over 7 equals 9.8, call it 0.86, 9.86. 9.86 meters per second. Right, the average speed. You could see that it would drop down a bit below the 12 due to this. Alright, due to this deceleration. So the average speed is 9.86 meters per second. Alright, what else is there? Oh, good. This is the end of question 8. And next time we look at question 9.